In this question, we want to determine a vector that makes an angle of 45 degrees with the x-axis, 90 degrees with the y-axis, and 135 degrees with the z-axis. Now, when no more specificity is given than that, the presumption is we're referring to the positive x-axis, positive y-axis, and positive z-axis. Well, the way to approach a question like this is to use our formula for direction cosines. The cosine of alpha is a over the magnitude of a squared plus b squared over the square root of a squared plus b squared plus c squared. Well, alpha is 45 degrees. Okay, alpha 45 degrees with the x-axis. So the cosine of 45 degrees is 1 over root 2. So we can say that 1 over root 2 is equal to a over the square root of a squared plus b squared plus c squared. This is important. Similarly, because we know that we make a 90-degree angle with the y-axis, we know that the cosine of that angle will be b over the square root of a squared plus b squared plus c squared. Well, the cosine of 90 degrees is 0. So 0 is equal to b over the square root of a squared plus b squared plus c squared. So clearly b has to equal 0. That's also important. Finally, the cosine of gamma is going to be c over the square root of a squared plus b squared plus c squared, where gamma is the angle made with the positive z-axis. Well, that angle is 135 degrees. So that means that the cosine of 135 degrees is equal to c over this quantity. Well, we know that the cosine of 135 degrees is negative 1 over root 2. So we can say that negative 1 over root 2 equals c over the square root of a squared plus b squared plus c squared. And this is very important right there. At this point, we get a little philosophical. We're asking for a vector. If you go back to the question, it says determine a vector that makes an angle. In other words, we can make the vector be any magnitude that we want. So I'm going to make a suggestion. Why don't we let the vector that we're looking for have a magnitude of root 2? Now, on first glance, you might wonder why we would choose that. But the reason why is because our denominators are the magnitude of the angle. The square root of a squared plus b squared plus c squared is the magnitude of v. And our denominators here are root 2 and root 2. We already know that b equals 0. So we're looking for a and c, and if we let the denominator be root 2, we're basically saying let the magnitude be root 2, and there's nothing wrong with that. Now, we can tell that the a to b to c ratio must equal a ratio of 1 to 0 to negative 1, because letting root 2 be our magnitude, we can think of the y-coordinate, the direction cosine for the y-axis being 0 over root 2, and that means that our a to b to c ratio has to be 1 to 0 to negative 1. And so we can therefore say let a be 1, let b equal 0, let c equal negative 1, maintains the proportion, has a magnitude of root 2, and we can use that as our answer. 1, 0, negative 1 makes an angle of 45 degrees with the x-axis, 90 degrees with the y-axis, and 135 degrees with the z-axis. And sometimes when you have a thinking level question like this, it's good to go back and check, does this vector in fact make those angles with the axes? And if you go back and use your direction cosine formulas, you'll see that it does. So we've gotten our answer.